snip of this, and I'll share my screen. Okay, here we go. All right, so it says use the graph of the function to answer the questions. First one says, is f of -4 positive? So at -4 is the x value. So you're going down to that y value. The answer is no, it's not. It's negative. But that's probably the easy one. So it says, next question says, where is the function greater than 0? Where is it above the x-axis? And this is the one you got to be a little bit careful on. It's from -3 to -1. So in this region right here, and then again from 1 to 4. Okay. Now it says, okay, so since it's greater than 0, we're going to go, 1, and then I think it wants a bracket on the one on the right there at 4, because it's completely above above 0.
And when we put the u value?
Yeah, sorry, u. This one wants u. That's not Pearson. Your Pearson wants a comma. This one wants a u. Okay, good.
We put a bracket at the end because it's not directly on the line.
Yeah, it includes 4 because 4 is above the x-axis there. It's a little bit odd, but they do. And then for the last one, it's just, where does it hit the x-axis? Where does it cross or touch?
So we have -3, -1, and +1.
Yes.
Oh, okay. Okay, I'll enter in those values right now.
Okay.
Okay, perfect. Yeah, I'll share my screen again.
Okay, sounds good.
Okay, that one was simple. Yeah, I think. Share.
And you're welcome to, say, okay, I think I've got this one down. Let's move to another one, or we can work through them all, or I can scan your screen while you're entering the answers. But let me snip this one and go back here. All right, so let me share my screen. Okay, so the graph, to answer the questions, g of -1, that is positive. That's that point there. So we can do a yes. This time the order switch, where is g of x equals 0? Only at 1. Only at value of 1, the only place it crosses. Now this one we want where it's less than 0. So it's less than 0 from 1 to 5, and 5 is included in that. But at 1, it's exactly 0. That's why it's not a bracket.
Okay. So we didn't start at -2 because it's asking below.
Below. So you just care about where. I'll even color code this a little bit better. This is below.
So it's just 1 to 5. Okay.
Yeah.
That makes sense.
Yeah. It's usually the words are more meaningful than a definition. We say above or below, or hits or crosses. Those usually mean something.
Yeah. Okay. Yeah, I will switch to a different topic.
Okay.
Yeah. Okay, I'll share my screen. Okay. And I have this one. It's like stretching or like shrinking.
Yeah.
I kind of get stuck on these ones.
Okay. Yeah, let me snip this in. All right, let me share my screen back and forth. All right, so I'm gonna just zoom this in a little more. We're actually gonna do the second one first because I think it's a little bit more intuitive.
Okay.
For that. So that this 2 on the outside it's a vertical stretch by 2. Vertical, it's more intuitive. So that means everything, and you're generally just looking at the 2 endpoints. What some students do is they actually label the endpoints so that they can figure out what to do. This affects the y value only. So you multiply the y value by 2.
By 2. Okay.
Okay, and then same thing here. Okay, now some students are more visual. I'm more visual. So like I'm like, oh, that goes up to 8. It was at 4, it goes up to 8. I should do that in a different color. Goes up to 8. And then same thing here. Oh, it was at 2, goes up to 4. Like that. So you're using that tool there. I think you can just pick the 2 endpoints and snap it in. You can do the ordered pairs if you need.
Yeah, I just counted because I'm also just like visual, so I'll just usually like count.
Yes.
Okay.
Let me know when you get that down. We'll go up to letter A and make sure and just double check that it's snapped at the right places, because it's easy to miss by 1 and you have to redo it.
Right. So -2, +4, and then +2, +8. Yeah, I got those in.
Okay. Now the one above is a horizontal, and the reason it's horizontal is because it's inside parentheses.
Okay.
And this is actually usually taught wrong in high school by most instructors. So you end up having to, it's a horizontal stretch when it's less than 1. It's less intuitive. So again, kind of need to look at those 3 endpoints there, and you're pulling it out this time. Okay, you might think, well, why isn't it just 2? A 2 ends up going the other way. So these pull out to double, so it goes from 2 to 4, and then -2 to -4, but 0, 0 stays the same.
Okay.
And it's all because of that. That means to get wider.
Okay, I'll write that down.
Okay, and then we can, if you get another one of these, we can maybe use the formula, but it might be slightly different.
So is it like the x value that change? It's the x value that changes.
Yes, that's exactly right. Whereas in the other one, the y value changes.
So it's just gonna be.
And you can't stretch 0. That's why you just leave it at 0.
Okay. So it's at 4, 4, and then -4, +4. -4, draw, raise.
This one you probably have to use 2 line segments to get it.
Yeah, that's what I just did. Okay. Okay, and I got it correct.
Perfect.
Okay, so I'll share my screen again. Okay.
Okay, good.
So the first one's just like the first one we did. It's just a stretch of 2.
The letter A is inside parentheses. The 2's inside parentheses, so you have to. It's the opposite. Instead of getting wider, it gets narrower.
Oh, okay.
And that's what you're gonna have to remember for the test. Now let me just share my screen, because it's very subtle, but it's like a huge difference between them.
Right. So inside parentheses means a wider stretch.
Well, no, it depends on the number inside the parentheses.
Okay.
So if this number is greater than 1, it's a let me think of sorry. It's a compression.
Compression. Okay.
If the number is less than 1, it's a stretch, and that's what we saw in the last problem.
Okay. I'll write that down.
So and you were wise. You said, does it only affects the x value. So the x values compress in, they move in.
So we're dividing by like 2 ultimately.
Yes. So this is your new one. And that's why sometimes it's better to write the coordinates. I can't say for sure. I mean, if you're really mathy like me, you're like, yeah, write the coordinates. But as a student, I'd be like, well, I don't know if I think that's the right thing to do. But it's the x value that changes. You divide by 2.
Yeah.
Okay, and then similarly, the next one, 2 and -4, it's the x value that changes, not the y value.
Gotcha. Yeah, I like to write down the points so I know like I won't mess it up.
That's good. That's good. Yeah. No partial credit on these.
Yeah, right. Okay, we can do the next one.
All right, so the next one is you look at where the number is, and this time it's on the outside of the function. So that means it's a vertical,
Vertical.
which means it affects y,
Mhm.
the y value. So if we write the three coordinates, -4, 2,
Mhm.
and then -2, -2, and then 0, 0. 0, 0 is not affected.
Right.
You can think of it as a multiplier when it's on the outside. It just multiplies the y value. So 2 goes to 1/2.
Mhm.
You're multiplying it by 1/2.
Right.
-2 goes to -1,
Right.
and then half of nothing is still nothing.
Oh, okay, gotcha.
So it looks like this when you're all done.
Why is she changed? Oops. Okay, I think I typed some, wait, hold up. So it's negative. I typed something incorrectly. Let's see. Well, I didn't submit it yet. So it's 0, 0, and then negative.
2, -1. Yeah, it should look like the red in the graph.
Yeah, which I'm looking at, and then -4, and then which is +1. There we go. Okay. Let me submit. Oh, I got that one.
All right, fantastic.
Yeah. I'll just share one last time with this topic. Cause I got confused on these ones. Like I tried figuring out on my own. I guess I kept mixing up whether
Yes, it's very easy to do because they give you one of each time, and sometimes
Yeah.
it's a stretch, compress. Sometimes it's it's just that's telling your mom. I mean, it's really good for learning. It really is, but it's hard when you're getting negative feedback all the
Yeah.
time on these
Yeah.
things. So I would always do the one that like I felt more comfortable with, which is the one on the outside. The one on the outside is the more intuitive one. That means each of your x coordinates, I'm sorry, each of your coordinates, the y value is affected. So we've got 0, 0,
Mhm.
2, -4, and then 4, -2. So the y values are what are affected.
Mhm. Could you share your screen?
I'm so sorry. I
Oh, you're fine.
apologize.
No, you're
It's
fine.
you're the last lesson of the day, I think. So sometimes that happens.
Yeah, no worries. Yeah. Okay, there
So
we
you can
go.
see I already got a fair number of the way through this.
Yeah.
Um,
I wrote it down as well. I was following.
yeah, the y value is what's affected, and then the x value remains the same. And then you just your sanity check is like, okay, does it actually look kind of the way I think it should
Right.
look? Which is like, yeah, it's vertically like half.
Yes. Yeah, this is actually pretty simple.
Yes,
Yeah.
that one's super intuitive.
Yeah.
The inner one is not. It's very different. Let me make sure you get this one.
Mhm. Yeah, I got the points. Yeah.
Okay. For graph B, this when it's on the inside, it's a horizontal, and because it's less than 1, it's a stretch,
Okay.
which is different than the vertical. The vertical, when it's less than 1, it's a compress.
Mhm.
I don't make the rules, just that's what it is.
Oh, it is. Yeah.
So we'll label the points 0, 0, 2, -4,
Mhm.
and 4, 0. This affects the x. That's also a good thing to write down.
Right. I did check.
So it's the reciprocal of this is what you do to the x value.
Mhm.
So instead of it's ×2 on the x value, the reciprocal of 1
Okay.
×2. So it becomes the first one's still 0, 0. Then it's 4, -4,
Right.
8, 0. Now when we graph these,
Mhm.
you'll see what I mean by the stretch. It should fit what we just said here, which is, yeah, okay, it stretched it out wider.
Yeah. Oh yeah, yeah, there's a big stretch. Okay, perfect. Got that one down. Okay, I'm gonna move to a new problem. Okay, I'll share my screen again. This one's like functions now.
Okay, yeah,
So
you can
just,
start.
start
Whenever
it.
you're ready.
Yeah.
All right, let me grab a snip and then remember to share my screen.
Mhm.
All right, I'm sharing my screen now.
Mhm.
Okay, so this notation, this H over G
Mhm.
of 5, what this means is you find H of 5 and divide by G of 5. So you have to put 5 in for X in both
Okay. Yeah.
of these. Now, you know, you're on lockdown, I think, for some of this stuff. So you may want to get comfortable using the Alex calculator if they give
Okay.
you one on this one. I don't know if they do or not.
We're allowed to use like a hand calculator,
Oh,
which
good.
I have in
Oh,
my
good.
hand right now.
Good. So just you know, make sure this is okay. Let's see here. It's 5 squares 25, 75. So it's 70 on top.
Yeah.
On the bottom, you got 8 times 5 minus 7, which is 33.
Mhm.
Those do not reduce. If your calculator, if you got like a TI 83, 84, you can do a math,
Yeah.
enter, and
Mhm.
it'll reduce the fraction
Okay.
you need
Mhm.
for that.
Oh, so basically you're just plugging in the values that it gives.
Yes.
you, what you need.
Yes.
Okay.
For part B, it says values that are not in the domain of H over G. So
Mhm.
there's only a couple things in math that are really bad. The first one is to divide by 0.
Mhm.
So you look for where the bottom, where the 8x minus 7, you've got to figure out where 8x minus 7 is equal to 0, because that's what's on the bottom. That's your G.
Okay. The G.
And you're just solving for X, and you get, okay, it's 7 over 8. So that means if X is 7 over 8, you're dividing by 0, which is a sin in math.
Okay.
Can't do that. And programming, but so that is the only exception. Think of it as an excluded value.
Okay, gotcha. And is it the denominator of
Yes.
every time like you have an equation?
Yes, the denominator can never be 0.
Okay, gotcha.
Never, never.
Okay. Okay, I'll share my screen again.
And this is all likely review. You probably saw this in a previous class.
Yeah, I definitely did. It's definitely been a while.
Yeah.
So it was confusing.
All right, let me grab a snip of this. All right, so again, just like the last problem, you've got to find G of 2 and then F of 2.
Yeah.
So G of 2 has got a little bit more going on. It's 5 plus 2 times minus 5 plus 2, which is 7 times negative 3, which is negative 21. F of 2 is 3 minus 2, which is just 1.
Right.
So this is negative 21. So sometimes it works out nicely.
Yeah. Simple.
For part B, it says to figure out where G over F. So your F is 3 minus X, like it's 5 plus X over minus 5 plus X over 3 minus X, but your attention is on the bottom.
Bottom, the denominator.
Where does 3 minus X equal 0 when X equals 3?
Okay, that was super simple.
Okay, so that's the excluded value.
Gotcha.
And you'll maybe do interval notation later on in this.
Yeah. Okay, yeah, that was actually pretty simple as well. Okay, I'm picking another topic. Yeah, I guess I can do this one.
And if you ever get like a, what do they call them? Something check,
Like knowledge check.
knowledge check. I mean, we can go through that too together.
Yeah,
No,
I got stuck. I already did the last one before my exam, so. Yeah,
okay. All
I have
right.
this one here.
All right. Yeah, so this one, share my screen here. This one, a little bit more to do. All right, so it says graph all vertical and horizontal asymptotes of the rational function.
Mhm.
So the vertical ones, they
Mhm.
come from when you set the denominator equal to 0. So 3x minus 9
Mhm.
equal to 0, and you solve for x. So you add 9 to both sides, and then you divide by 3. So x equals 3.
Mhm.
So there's a vertical line right there, and that's you definitely want to do that, first.
Mhm.
Knock that one out.
Yeah.
So for the horizontal, there's a bit more to say here.
Mhm.
So we're gonna have to just talk a little bit about what's called degree
Mhm.
of the numerator and the degree of the denominator.
Okay.
Does that mean anything to you? Wait, the degree?
Not that I can recall.
Okay, that's fine. That's what I'm asking, just to know how deep to go in this. So the degree
Yeah.
of the denominator is 1 because it has an exponent of 1 in
Oh,
the,
okay. Okay. Yeah.
okay.
Yeah.
The numerator is 0 because there's no x.
There's no X.
I
Okay.
mean, it's really x to the 0, but it's not written. Okay.
Yeah.
So this is what's considered a case 1. I call it
Mhm.
case 1 or type 1. When the degree of the numerator is less than the degree of the denominator, the
Mhm.
horizontal asymptote is always y equals 0.
Okay.
So with this case, now I don't know what we're going to
Okay.
see in the next problem. It might be case 2,
Mhm.
but when the degree of the numerator is less than the degree of the denominator, it's always y equals 0, and that's the horizontal line right there. And
And
that's
do I
all.
have to graph that on now?
Yes,
Yeah.
yes,
Okay.
yes, you have it. Must do that.
Okay. So I'll check it. Okay. Got it correct. Oh, yes. The next one's different. I'll share screen.
Okay, is this the next one?
Yes.
Let me talk you through this one. Okay.
Okay.
So let's do the horizontal one first.
Okay.
It is different in the last one. It's different in the last one in that it's different numbers and all that, but the degree of the numerator, is there an x term in the numerator?
No.
No, so its degree is 0. In the denominator, its degree is 1. Okay, because it's x to
there
the
is an
1
X there. Yeah.
next there. So since the degree of the numerator is less than the degree of the denominator, just like the last problem, it's y equals 0 is the horizontal asymptote.
So y equals 0 when the numerator does not have about like it's less than 1.
When the degree is, and we're looking for an exception to this, because like I don't want to just say like they're all 0, because the next one might be an exception. So just waiting on you to I guess put that horizontal at y equals 0, and then
Could
we'll
you
talk.
share your screen? Because
Oh, I was trying to talk you through this one,
yeah. Oh, okay. Yeah.
but I can grab a snip here if you'd like.
Yeah. So we're okay. So we would graph this one right
Yes,
here.
yes, just like that. That's perfect.
And there's no X that we can graph.
No, there is. We're going to get to that. We're going to
Okay.
get to that. So to get the vertical one, you set the denominator equal to 0.
0. Okay, great.
All right, so I'll share my screen here for that.
Okay.
Just trying. So I've done this with students a number of times, that eventually there is a little bit more on talking you through the problems, but
Yeah.
I'll share my screen here
Yeah.
to get this. So you already got the horizontal down. Great. Got that one down. The vertical asymptote, VA, is when the bottom is equal to 0. You have just the
Okay, so
bottom
denominator
equals.
will always be 0.
Yes.
The vertical asymptote. Okay.
Yes. So you add 2 to both sides. Minus x equals 2, divide by -1. So x equals -2.
And that's okay, the vertical asymptote. Yeah.
Yes, yes.
Okay. Okay, and then I guess I'll just share my screen and then.
Yeah, I'll snip
And
it
then
in.
I'm gonna try.
Okay.
Yeah.
Yeah, this is another good one to do. This one's just like the last one, really. The horizontal is y equals 0 for the same reason.
Yep. And then I'm gonna write this one equal to 0. -2. So x is -7/2.
-7 over -2.
-7. Yes, I wrote that down. Yes, -7 over -2.
Which reduces to 7/2 or 3.5.
Mhm.
And you'll notice when you grab the vertical one that it'll snap between the points.
So could I type it like?
No, you don't need to. You just go to the vertical one.
Nope, sorry,
Yeah.
vertical one, yeah.
And if you go to the graph, it's gonna see how it snaps between there, but you want you want positive 3.5 to the right. Right, one more. There you go.
Wait, so when the two negatives cancel out
Yes.
to a positive, that's why so x is +7/2.
Yes.
Which is 3.5. Okay.
Yes.
Okay, that was cool.
And that looks good to my eye here.
Okay, perfect. Okay, okay, I got the hang of it, but these ones. Okay, I'm gonna pick. I guess okay, yeah, this one. These are. I don't know if this one's a little longer.
They're not. Well, I mean, they're all the same to me. So don't.
Okay.
You should pick the ones you think you can't do on your own.
Yeah, I skimmed at this and I was like, this seems a little nerve-wracking.
And this, I'm here to help you. They're all the same to me. Like there's no like, oh, I hope she picks this one. They're all like. All right, so let me.
Yeah, word problems scare me. So I see a bunch of words. And I'm like, oh, I don't want to do this.
Yes. I was just working with an SAT student, and it's the same problem. They're like, story problems I don't want to do.
Yeah.
All right, let's get on to the I guess the mathy ones here. Okay. So P inverse of X. To find the inverse, it's a recipe. You first switch the variables. So let's let me rewrite this here. Let's go P equals, well, they're using X. All right. I don't want to do this. I guess I'll go P equals 0.4n plus 6.6. So you switch the variables. Okay, and then you solve for the other variables, like you'd solve for P. Okay. And normally it's like y equals 0.4x plus 6.6. So if you prefer that, we can switch the x and the y. But we're just solving for P in this case. So it's n minus 6.6 equals 0.4p. Divide both sides by 0.4. I'm just switching sides here. So P equals n minus 6.6 over 0.4. So in terms of like what you're going to do in this box here, it wants it in terms of x. So it's weird, but that's okay. So it's x minus 6.6 over 0.4.
Gotcha. Okay, got that one down. All
right, now to do part C, we're going to go back part A. Because you have the inverse, you just substitute 8.8 in for x. 8.8 minus 6.6 over 0.4.
Oh, okay, gotcha.
And then you reduce as much as you can, which looks like it's 5.5. Please check that.
Yeah, I'm noting it right now. Yeah, 5.5.
Okay. Yeah. So to answer part A, you first go back to the units of the original. The units of the original is price in dollars for n grams of vitamins. So the inverse is the flip of it. N grams of vitamins for P dollars. And then we're looking for the one or price of X dollars. And then we're looking for the one that matches up to that. Price of X. So I like this one. To me, looks the best. It's never the reciprocal. It's not this ratio. It's going to be one where the wording is flipped of the units. That's the shortcut here. So I really hope all these are correct. If they're
Okay.
not, let me know, but
Yeah.
make sure
Okay,
you
yeah,
use X.
I'll press check and see. Yep, those are all correct. Okay. Okay, I'll share my screen. So the word like, or I guess like the answer that is like the sentence, it's just what best fits the situation.
Yeah, but it's always reflecting back the units that you're originally given. Just flipped.
Mhm.
The inverse is it. The inverse is the flip of input and output, essentially. I can give you some better analogies, but let's just keep going through this. Let me share my screen. Okay, so let's start down here with the inverse of X. So again, you've got L equals 1.25 T plus 82. You switch the variables.
So
and then you solve for L, or solve for the variable in question. T minus 82 equals 1.25 L. And then you divide both sides by 1.25. So L equals T minus 82 over 1.25. Now they want it in terms of X, so you're going to use X there.
X minus 82. 1.5. Okay, gotcha.
And then for part C, you're going to substitute that value of 130 in for the X. Okay. And you should get something like sort of reasonable, nothing weird, because they're designed that way. So that's kind of your check here to like, did I do it right? Do I get something?
The 130 goes into the T.
Well, yeah, or
the
X.
I guess now.
Yes,
Yeah.
yes. I mean, there's a reason they switch that. It's not helpful for you as students, but just remember to put it in for the variable that it's asking for.
Okay, yeah, I'm using my calculator. Which is 38.4.
Okay, good.
I also got, yeah.
So for part A, you go back to the units here. It says it's the amount of liquid in liters in the tank after T minutes, and you just switch them. So it's like time for a liquid,
yeah.
going backwards. So it's never ratio, it's not reciprocal. I could see down to 2 answers, and the order matters. So time,
which is the first one. Yeah, I figured the first one.
Yes.
Okay, gotcha. Okay, perfect. Yeah, I'll share my screen and then try the third one on my own.
Okay.
Yeah. Let's see. Okay. Write this down. And then I'm going to switch the variables to find this one. So it becomes. So would I write it as H equals 48.5 minus 2.5
T. Yeah, I like that. Yeah. Big T. Yeah.
T. And then I'm trying to find T, so I'm gonna move over the 48.5.
Okay. I like it. Yep.
Yeah. And this 48.5 equals let's see. By negative 2.5.
Yeah, I'll watch you enter it as well, and make sure you switch to X. Make sure that it's
X. So would it be? I have H written down.
Yeah, yes, use X. Use X though.
For H. Yeah.
Yes. Yeah. Good.
48.5 all over -2.5.
Yes, that's what I've got as well.
Okay. Then I plug in 33. Let's see. Yeah. And that's going to be positive 6.2.
That's what I have as well.
Okay. And then we went from even below the temperature at the Celsius at the height, which is h of kilometers. So backwards, it's going to be this one.
Yes, I agree.
Perfect. Okay. Okay,
Moment of
great.
truth. Good.
Yeah, perfect. Okay. I guess, yeah, I can actually, there were some other ones that I was looking at, I wasn't sure.
So my tip would be if there's ones where you have multiple like things to input in each one, that
Yeah.
those are probably better for us to work on because they're
Yeah, let's do this one.
there's more risk each time you
Yeah.
have to figure it out on your own.
Yeah,
So.
let's do this one.
All right, so let me grab this here.
Mm.
Yeah, they really give you quite a bit on this one.
Yeah.
All right, let me share my screen.
Mhm.
And so we're doing inverses now.
Okay.
And let's do so that like this is very much related to what we just did. I'm gonna start with the one on the right,
On the right,
first.
okay.
So like just like you were doing, y equals x plus 6. This is the more standard way of doing it. And then you switch x and y. So x equals
Y plus 6.
y plus 6. Okay.
Huh.
And when you solve for y,
Mhm.
y equals x minus 6.
Right.
Now, if these are the same, which they're not in this problem, but if
Mhm.
they were the same, it would be x and x that goes down
Okay.
there. Okay. But they're not. The other ones actually are inverses of each other. We'll get to that though.
Mhm.
So in terms of like, what do you do now? Well, I think we did this last time. You take g of x for the first one, f of g of x. You
Uh-huh.
take the g of x and you plug that in for x.
Okay.
So it's like x plus 6 plus 6.
Plus 6. Because and we're only gonna plug them in when they're not the same.
That's right. When they're, yeah. This is kind of a shortcut. So it ends up being x plus 12 in that box.
Mhm.
So for the next one, for g parentheses f parentheses x, g of f of x,
Uh-huh.
you just go the other direction. You take, I'll do it in a different color here.
Mhm.
You go x plus 6 now into that one.
Okay.
And you're like, well, it's the same. I'm like, yeah, it's the same, but that doesn't mean
Mhm.
they're inverses. It's
Yeah.
x plus 12.
X plus 12. Yeah.
So these are not inverses.
And they're not Y because they're the same.
Because it's not the same. So when you do the inverse, and you do have to learn how to do the inverse in this class. That's why I was showing it. And I'll show you it again on this one on the left. If they're the same, then they're inverses.
Mhm.
And when they're inverses, f of g of x equals x and g of f of x equals x only.
Yeah, so the answers are the same, and you're saying if they're not the same, then they are inverses?
We're talking about different sames. So
Okay,
sorry, there's a lot here. So I'm talking about these being the same,
okay,
not the answers.
without the answers, right, okay,
Okay, this will make more sense when we actually get an inverse that is the same. So let's
okay.
look at the one on the left here.
Uh-huh.
Y equals 1 over 4x.
Mhm.
So you're going to switch x and y. X equals 1 over 4y.
Yeah. Mhm.
And to solve for y here, we're gonna cross multiply. I think that's probably the best strategy for you. So it's x times 4y equals 1 times 1, which is just 1.
Yeah.
So on the left here, though, you got this 4xy, and remember, we're solving for y.
Y, yeah,
So you want to undo that 4x, you divide both sides by 4x.
X to
And
get the
wouldn't you,
Y one.
and wouldn't you know it, that's exactly the same as what you started with.
Okay, right.
Okay. Now, so so what I was trying to say is when the one you start with and your inverse are the same,
Mhm.
that means automatically that this composition is x, but I'm going to
Okay.
show you that for this next one.
Okay.
So this f of g of x means to take g of x, which is 1 over 4x,
Uh-huh.
okay, and plug it back into, you're plugging that into the other one for 1 over 4x. You're plugging 1 over 4x in for x.
Okay.
So it's a lot going on here, but it's 1 over 4x in for x.
That's right.
So you get 1 over 4. This ends up being 1 over 4 over 4x.
Yeah.
The 4's cancel, so you get 1 over x.
Mhm.
And then the reciprocal x over 1 cancels, and you're just left with x in the numerator.
Um,
And if you didn't get all that, that's okay.
No, I
because
got
we're
all
gonna
of it. That makes
okay,
sense.
good. So that like the shortcut is that most of these, one is going to be the inverse of the other.
Mhm.
One of them will be, when they're inverses, the composition is x.
Composition is X.
Yes.
Mhm.
So these are inverses of each
Mhm.
other.
X. Okay. So we're not inverses. Okay, got it. Okay.
Okay, so whenever you're ready, you can share.
Oh, it says. Oh, I didn't. Oops. This. Okay, got it. Yep. I'll share my screen again. Okay.
All right, let me grab a snip here.
Mhm.
Okay, let me share. All right, so let's not do the, sorry, I'm not sharing yet.
Mhm.
Just one more click. Always another click. Let's not do the whole like find the inverse. Let's just do like what it's asking for here.
Right.
It's saying take g of x and put it in for x.
X. Okay.
Okay, so that means minus, and then instead of x, minus 3x
Mhm.
over 3. And like when I substitute, I always do it in parentheses.
Huh.
Okay, so the two negatives cancel. That becomes positive 3x over 3, which becomes just x.
Okay.
And you might think, well, the other one must be x. Well, maybe, but don't jump to that conclusion quite yet.
Okay, gotcha.
Okay. So now the other one is okay, take f of x and plug that in for x.
Okay.
So it's like minus 3 times x, but instead of x, it's minus x over 3.
X, 3. Okay.
So then in the numerator, you get 3x because the two negatives become positive, x on the bottom.
So it's X. So both of those are just X and X.
Sorry,
Oh, that was
sorry,
3.
it does become x. Yeah, good.
Yeah.
Yes. So these are inverses.
Inverses when they're both X.
Both x. Okay.
Gotcha.
All right. So now we're gonna do the same thing for the next one here.
Mhm.
I'm running out of room here a little bit, but I'll make it clear. So the first one is take g of x and plug that in for x.
Mhm.
So that's 2x plus 1 in the numerator,
Mhm.
minus 1 divided by 2.
So that's just X.
Does equal x.
Mhm.
But you have to try the other one because
Right.
it may not work both ways.
Mhm.
So the other one is take x minus 1 over 2, plug that in for x. So that's 2 parentheses x minus 1 over 2 plus 1.
And
So the 2 from the outside cancels with 1 on the bottom.
okay.
So it does equal x. So
So
yes,
it's
they
x
are
minus 1 plus 1, which is or
just x. Yeah.
just
X minus 1 plus 1 is x.
1,
Yeah.
which is x.
Yes.
So those are also inverses of each other.
Yes. Yes.
Okay.
And we didn't have to find the inverse. So that was probably a mistake to do that in the previous ones. You probably should just try substituting them in since you have to do that anyway to get the answer. But
yeah. Okay, I'll submit it. Okay, and then we can just do this last one and then call it a day.
Okay. So why don't you try the one on the right, and I'll work out the one on the left. I'll share my screen here shortly.
Okay.
But the one on the right's much more straightforward when they're linear.
So it's asking. So it's asking me to put G first into F.
Yes.
Yes. Okay. So, let's just. So if x equals 4.
I've got minus x plus 4.
I might have.
Right, because you're literally replacing the x. You're not subtracting it from the x. It's taking the place of.
So it's just minus x plus 4.
That's correct. Yeah.
Oh, so you're not going to write it equal to 0. Okay, that was my mistake.
No.
I wrote it to equal 0, which is not what I should be doing.
For the other one though, it's a little bit more difficult, but you're taking that top x plus 2 and plugging it in for x now.
Which
now be careful that you're negating everything that you're substituting in for x.
Okay, so I got a little stuck. So we're taking the top value because it's G of and so we're putting in x. Sorry, F for
Yes, exactly. So because I've got 2 different things going on here, it gets confusing for that.
Okay.
So this simplifies to minus x minus 2 plus 2, which becomes minus x
plus 4.
No, the negative distributes to both.
Oh, right. I
Yes.
not forget that. That will be a big mistake. There it goes. No, yeah.
So these are not inverses because they're not the same.
They're not the same. Yeah.
Yes. Okay.
Yeah.
Right. Now we are pretty much out of time, but I'll just quickly go through the left one here. They are inverses. It's minus 6 over x.
Right.
And so when you multiply by the reciprocal on the top and the bottom,
you get the x.
Yes. And so they actually end up both being x, and they are definitely inverses of each other. So
okay.
All right. Thank you, Sophie, for letting me help you tonight. I think the format's working out well for you, so I hope to see you schedule in the future.
Yeah, it definitely is.
If you see if you need help and I don't have a time available, please just text or call, and I'll do my best to accommodate you. But thanks again. Hope you have a great rest of your night and good weekend.
Well, thank you so much. I appreciate it.
You're welcome. Okay, bye now.
Bye-bye.